Chernobyl disaster, 1986. On April 26, 1986, a catastrophe occurred at the Chernobyl nuclear power plant in Ukraine, leaving an indelible mark on human history and global consciousness. The explosion of the fourth reactor was the result of a failed test conducted under non-standard operating conditions. This led to a catastrophic release of radioactive substances into the atmosphere, which spread over vast territories. 2 people died at the scene of the accident, and in the following weeks, 28 plant staff members succumbed to radiation poisoning. However, the long-term consequences of this tragedy are far more extensive. As a result of the disaster, more than 116,000 people were evacuated in the first weeks, and in 1987, another 220,000 people were resettled from more remote regions. Radioactive contamination affected not only Ukraine but also Belarus, Russia, and many European countries, including Sweden and Finland. A 30-kilometer exclusion zone was established around the nuclear power plant, access to which remains strictly limited to this day. Chernobyl left a profound impact on the health of millions of people. Many suffered from cancer, thyroid diseases, and other chronic illnesses. Numerous cases of genetic anomalies have also been recorded, which will likely be passed on to future generations. The disaster is associated with economic and environmental losses, as well as global changes in nuclear energy policy. Many countries reconsidered their nuclear programs, tightened safety standards, and implemented stricter control measures. Bhopal gas tragedy, 1984. On December 3, 1984, one of the most tragic disasters in the history of the chemical industry occurred in the Indian city of Bhopal. A leak of the highly toxic gas methyl isocyanate from the Union Carbide plant led to the immediate poisoning of thousands of people in the vicinity. Approximately 3,000 people died in the first hours, and in the following years, the death toll rose to 15,000, 30,000 due to the consequences of toxic exposure. The environmental consequences were extremely destructive. Pollution of air and water, along with the destruction of ecosystems, led to long-term problems in the region. Thousands of people suffered from chronic illnesses, including cancer, respiratory diseases, and kidney problems. The plant, once a significant economic center, became a symbol of technological accidents and negligence in handling hazardous substances. The Bhopal incident led to the creation of new safety standards in the chemical industry, stricter regulations on emissions of hazardous substances, and improved working conditions in dangerous enterprises. This case also served as an important catalyst for enhancing environmental safety legislation in various countries. Fukushima disaster, 2011. On March 11, 2011, Japan experienced the strongest earthquake in its history, which triggered a catastrophic tsunami. These natural disasters had tragic consequences for the Fukushima Daiichi nuclear power plant, as powerful waves flooded part of the equipment and disrupted the cooling systems of the nuclear reactors. This resulted in several overheating incidents and explosions, leading to the release of radioactive materials into the atmosphere and the ocean. Approximately 160,000 people were evacuated from nearby areas, and the zone around the plant, which at one point covered an area of up to 20 kilometers, was declared unsafe for human habitation and remains uninhabitable to this day. Issues related to radioactive contamination and long-term health consequences for those exposed to radiation remain pertinent. There is varying data on the number of people affected by cancer and other diseases, but exact figures remain uncertain. Fukushima also significantly impacted global nuclear energy policy. Japan suspended or reviewed its nuclear program, and many countries, including Germany and Switzerland, began actively reducing their reliance on nuclear power. New international safety standards were introduced, and measures to prevent similar incidents were tightened. Environmental disaster in the Aral Sea, 20th century. The catastrophic reduction of the Aral Sea in Central Asia became a prominent example of how ill-considered human actions can lead to irreversible environmental consequences. In the 1960s, extensive water diversion from the Amu Darya and Sur Darya rivers for agricultural needs led to a significant drop in the sea's water level. By the late 1980s, the Aral Sea had almost completely dried up, transforming into several shallow water bodies. As a result, the region's ecosystem underwent severe changes. The extinction of many fish species, the disappearance of vital aquatic ecosystems, and the loss of essential sources of life for local residents occurred. Additionally, massive dust storms emerged, which not only polluted the air but also spread toxic substances. Residues of pesticides and salts accumulated at the bottom of the drying water bodies. Due to the deterioration of water and air quality, outbreaks of respiratory illnesses, cancer, and other chronic diseases began to arise. Local economies that once depended on fishing also faced significant transformations. However, despite the magnitude of the disaster, steps have been taken in recent decades to restore the ecosystem, such as projects aimed at restoring water inflow to certain areas and rehabilitating natural resources. Pollution of Loch Ness, 1982. In 1982, a chemical plant located near the famous Loch Ness in Scotland experienced a leak of toxic chemicals, resulting in the contamination of the waters. The pollution of the lake caused a mass die-off of fish and other aquatic creatures, leading to a sharp deterioration of the ecosystem. Although no human deaths were reported as a result of the incident, the damage to the ecosystem was catastrophic and affected not only the flora and fauna of the lake, but also the local fishing industry. Local residents and tourists visiting Loch Ness felt the long-term consequences of the water pollution, as the lake's ecosystem was severely disrupted. However, due to numerous restoration efforts and water purification initiatives, the ecosystem began to recover gradually. This incident served as an important lesson for the chemical industry about the importance of monitoring emissions of toxic substances into natural water bodies. Texas City Disaster, 1947. On April 16, 1947, an explosion occurred at a chemical plant in Texas City, USA, becoming one of the largest technological disasters in American history. The cause of the catastrophe was a leak of ammonium nitrate, which led to a powerful explosion that destroyed much of the city and resulted in the deaths of 600 people. The fire lasted for several days and caused significant destruction to infrastructure. Thousands of people were injured, and the economic damage to the city was colossal. This incident underscored the importance of developing strict safety standards in the chemical industry, particularly in the handling of hazardous chemicals. Following the disaster, measures were taken to improve safety at chemical and petrochemical plants, and new methods of monitoring the storage and transportation of hazardous materials were implemented. Since Gush Mine Explosion, 1906. In 1906, one of the most tragic explosions in the history of the coal industry occurred at a coal mine in Sint-Gouche, Belgium. A methane explosion in the mine resulted in the deaths of 262 miners. The cause of the explosion was the accumulation of methane, which ignited from a spark generated by equipment. After the explosion, the mine was partially flooded, and rescue operations lasted for weeks due to the threat of further explosions and collapses. This catastrophe served as a catalyst for improving safety standards in coal mines across Europe. New ventilation methods were introduced, and stricter requirements for preventing methane and other flammable gas explosions became established. The tragedy in Sint-Gouche accelerated the development of legislative initiatives aimed at protecting miners' lives, improving working conditions, and ensuring safety in coal mining operations. Opal Factory Explosion, 1996. In 1996, a powerful explosion occurred at a chemical plant producing pesticides in the Polish city of Opole. The leak of chemicals led to severe environmental contamination and the destruction of several production buildings. The explosion and subsequent fire claimed the lives of 20 people and over 100 were injured. The environmental consequences of this disaster were significant. Air and soil pollution with chemicals jeopardized not only human health, but also the long-term ecological sustainability of the region. As a result of the incident, the authorities in Poland and other European countries intensified safety control measures at chemical enterprises and enacted new laws regarding the handling of hazardous chemicals. This case also served as an important lesson about the need for stricter measures to prevent chemical disasters. Piper Alpha Oil Platform Disaster, 1988. On July 6, 1988, a catastrophic accident occurred on the Piper Alpha oil platform located in the North Sea, resulting in the deaths of 167 people. The cause of the disaster was a gas leak that triggered a series of explosions and fires engulfing the entire platform. The fire was so intense that it destroyed communication and evacuation systems, complicating rescue efforts. This incident became the largest disaster on an oil platform and one of the most tragic incidents in the history of oil extraction. As a result of this catastrophe, safety requirements for offshore oil platforms were tightened. New emergency alert systems were introduced, technologies to prevent gas leaks were improved, and additional measures to protect personnel on the platform were implemented. Measures to enhance the effectiveness of rescue operations were also adopted, saving hundreds of lives in the future. Abacan Mine Incident, 2004. On March 14, 2004, an explosion of methane occurred at a coal mine in Abacan, Russia, resulting in the deaths of 108 miners. The explosion was caused by the accumulation of methane in the mine, which had not been detected in time. The explosion destroyed several levels of the mine, and rescue operations were complicated by numerous collapses and the threat of further explosions. This incident became one of the largest coal mining disasters in Russian history and prompted a revision of safety standards in the mining industry. Changes were made to legislation, ventilation requirements in mines were tightened, and measures for gas monitoring in mines were strengthened. New technologies to prevent such accidents were also implemented, and rescue services underwent additional training. Westport Technological Disaster, 1963. In 1963, an explosion occurred at a coal mine in Westport, New Zealand, resulting in the deaths of 19 miners. The cause of the accident was the accumulation of methane, which exploded from a spark generated by equipment. All the deceased miners were underground, and rescue operations were extremely challenging due to the danger of new explosions and subsequent collapses. The tragedy in Westport led to changes in approaches to mine safety in New Zealand. Stricter rules for working with methane and other hazardous gases were introduced. Ventilation and safety methods in mines were improved. Additionally, the training of rescue teams for quick responses to such accidents was enhanced, increasing the level of protection for miners' lives. Exxon Valdez oil spill, 1989. On March 24, 1989, in Alaska, the supertanker Exxon Valdez collided with a reef, resulting in the largest oil spill in U.S. history. Millions of liters of oil contaminated the ocean waters, causing devastating damage to the region's ecosystem. Thousands of marine animals, birds, and fish perished, and the ecosystem was disrupted for decades. The environmental consequences of this disaster were catastrophic. Ocean waters, coastal zones, and ecosystems were heavily polluted, and the recovery of these natural resources took years. This incident served as a catalyst for changes in marine safety and ecology. In response to the disaster, stricter safety standards for oil platforms and vessels were introduced, as well as laws for preventing oil spills and cleaning up contaminated water bodies. Taiwan chemical plant explosion, 1998. In 1998, a powerful explosion occurred at a chemical plant in Taiwan, resulting in the deaths of 29 people and hundreds being injured. The plant, which produced chemicals, suffered severe damage. The fire that broke out after the explosion lasted several days, destroying significant equipment. This incident became one of the largest in Taiwan's petrochemical industry. In response to the disaster, safety standards at chemical plants were tightened, measures for monitoring hazardous substances were improved, and new environmental and labor protection laws were enacted. This case highlighted the importance of adhering to all safety regulations in such hazardous industries. Ufa Railway Station Disaster, 1989. On June 4, 1989, in Ufa, Russia, an explosion occurred due to the collision of two oil tankers, leading to a powerful explosion and destruction of nearby infrastructure. As a result of the disaster, 575 people died and hundreds were injured. The explosion and subsequent fire became one of the deadliest railway disasters in history. This tragedy led to significant changes in the safety of transporting hazardous materials. Stricter standards for the transportation of oil and petrochemical substances were introduced, and measures for monitoring the condition of railway transport and tankers were improved. Additionally, technologies for fire suppression and emergency evacuation were enhanced, helping to prevent many similar disasters in the future.